Welcome to Teammates' Senior Project Presentation, sponsored by GE Aerospace, the CNC Automated Part Handler, with Ethan Avery, Jasper Bailey, Jacob Kugler, Zachary Moore, and myself, Kayla Lett. GE Aerospace produces a variety of parts for both commercial and military aircraft. This project focuses on a part that goes inside the LEAP-1B engines which power the Boeing 737 MAX commercial aircraft. This project deals with implementing improvements to the existing manufacturing process of the LEAP-1B shroud. Prior to the development of the CNC automated part handler, an operator is responsible for loading and unloading parts from each station within the machining fixture. This included loading a raw casting into Station 1, placing parts into a part washer following deburring, and transferring mid-process parts in their subsequent stations. A safety hazard is presented when operators must handle the mid-process parts due to a buildup of sharp burrs on the shroud. To eliminate the need for operator to come into contact with these burrs, the CNC automated part handler was developed. The scope of this project was defined as a proof of concept. The required deliverables include a functional prototype of the designed tool and written suggestions for future development, as well as an official decision on whether the idea was feasible to pursue further. The design was guided by several key specifications, including a cycle time of 1 minute, a maximum force applied to the shroud of 300 psi, a maximum of 2 operator-to-part contacts for loading and removal, and a limit on the number and complexity of modifications that would be made to the original fixture. The part handler was created using a combination of custom and stock parts. A key feature to the design is the rotary union. This feature allows air to pass through the device required to operate the pneumatic fingers while eliminating the need for air lines, which become entangled when the device rotates 360 degrees. The tool is first loaded into the spindle. It then removes the shroud from Station 4. It is loaded into a drop box to be collected later. The shroud is then removed from Station 3 and loaded into the newly opened Station 4. It is tapped to ensure proper seating. The shroud is then removed from Station 2 and loaded into the newly opened Station 3. Finally, the air cylinder on Station 1 is activated to open the gate, and the shroud is removed, loading it into Station 2. A full shroud movement cycle is now complete. To begin a new cycle, the operator may open the HAAS doors, remove the finished shroud from the drop box, load a new raw casting into Station 1, close the doors, and hit cycle start. This process can be repeated indefinitely to create the shrouds required. Based on this successful cycle, it is recommended that this is a feasible idea to move forward with.